I'm going to start recording and what's up? All right, so let me start sharing my screen really quickly and it will just show up this screen right here. And let me just, oh, sorry, let me go back introduction. This is mainly all the introductory info. I was planning on making a video about this, but really, I think you guys can just read this initially right now. And so just AIME tests 15 questions in 3 hours, and then you can qualify further after reaching a certain score. But to take AIME, you need to take the AMC, which is 25 questions in 75 minutes. And these are the percentiles that you must reach for you to qualify for the AIME test. So AMC 10, 120, AMC 12, 100, or these percentiles, 2.5%, or 2.5% or 5%. So I think you guys, based on that, you guys can figure it out. And I'm pretty sure if you guys have any questions, just DM me on Discord to figure out whether you need any help understanding it. But I think at the moment you guys are able to do it. So let me go to the first session right here. And in this case, before I continue, a lot of these problems I'm going to be taking from either the Art of Problem Solving book or the actual test themselves. So like if you search up ANC 10 the 2015 or something, one of the first websites you'll find is the Art of Problem Solving, which has access to every AMC and every AIME, in fact, given within the last 20 years. And so it's a good resource if you want to take practice AMC and AIME tests. So I'm going to put let me put the link really quickly into let me put the link quickly into it's called the Art of Problem Solving. Here it is right here. And then this is the link where you can go get access to all these ANC and AIME tests. But in this case, these are very specific. The ones that I'm sharing right now, these are from the Art of Problem Solving Volume 1 textbook, which is called The Basics. And it will give you a lot of just like pretty much a lot of just information, exercises, and practice problems that will help you understand concepts that are tested on with both these tests. And so in this case, I'm going to start off a little bit easy just so that we can get into an idea of where we can start and where we can continue. And so I checked out all of your responses. Thanks to everyone who responded. And we're going to start working on circles and angles. And so I'm going to start off with just getting in definitions. Definitions are really important because if you don't know what the question is asking you, you're kind of screwed. So I would like, I'm pretty sure everyone knows what the center of a circle is, what the radius of a circle is. Does everyone here know what a chord is? Can you guys hear me well, by the way? Just making sure because my mic is a little bit farther away. Yeah. The diameter is also the chord. The diameter is the longest chord that you can make in a circle. And then, do you know the difference between a tangent and you guys know the difference between a tangent and secant? Just making sure. So, okay, so a tangent line, for example, is a tangent line that just grazes the circle. Like it doesn't go inside it, it just intersects it at only one point. It only touches it at one point. A secant is a line that goes outside the circle, inside the circle, and outside it. So this line here, this is a secant. This line here is a tangent. For a secant line, there are 2 points of intersection. For a tangent line, there's only 1 point. Oh, hello, it's my boss. Okay, so the secant, a secant is more general. It's a more general term for a chord. A chord. So a chord is essentially just. Let me just draw it out really quickly. A chord is essentially just any line drawn between 2 points on a circle. So like, why is it not drawing for me? Let me draw it in blue, I suppose. Okay, this is getting a little bit annoying. A second. Here. This right here is a chord, as you can see, connects 2 points. This right here is also a chord. This right here is also a chord. But the most important chord in any circle, that's not a circle. What? Oh, whoops. A secant is pretty much just like, it's basically generally just a line that crosses a circle. The chord itself is essentially the stuff that is contained within the circle. So yeah, you're technically right in saying that a secant is longer than a chord. And then, all right, let me draw another circle, hopefully one that's actually a circle. All right, now let's go on to, let me do pen. All right, and then, okay, so, all right, okay, so a circle right here. So a circle, it can be, so just to make sure everyone's on the same page, does everyone know the difference between chord, tangent, secant, and does everyone know the differences between them? Just making sure. Okay. And okay, so let me try. I don't know why it's not allowing me to draw. This is really annoying. Okay, here. So this is the diameter. A diameter, you most likely learned this in school. Essentially, a chord. It's the longest chord in a circle, in fact, that connects 2 points and goes through the center of the circle. And then 1/2 the diameter is the radius. So that means the diameter of the circle is equal to 2 times the radius, essentially. And that's basically what you need to know about the radius and diameter. But also, another thing that you could do is that so now let's talk about the circle itself. So I'm going to draw another circle really quickly. A circle can be split up into, oh, sorry, let me ask something really quickly. Let me just go over this. So let's say we have 2 circles that are surrounding each other, and they have the same, let's pretend that oval is a circle, and it has that point as the circle right here. Let's say this is a circle that is surrounded by another circle. If they have the same center point, that means they're concentric with each other. Concentric means same center, essentially. So 2 circles, if one of them is bigger than the other, but they have the same circle, it's concentric. So that's all you need to know about that. Now let's go into discussing major and minor arcs. Does everyone know what arcs of a circle are? Okay, I'll just explain it really quickly. So an arc is essentially just an arc is, let's say if I draw, it's basically just choosing a part of the circumference, essentially. So like right here, this is A, let's call this point A and point B. This is arc AB, essentially just a section of the circle. And then in this case, notice how you could describe 2 different areas. You can describe AB starting from here all the way to here, or you could describe AB going from here to here. One of them is longer than the other, and that's how we can differentiate between a major arc. The major arc is the bigger one, the big A to B, and the minor arc. The minor arc is a small A to B. And so that's just some terminology, but luckily, so as long as you figure out what arcs are, just generally know that arcs is essentially just a section of the circle. And then if I draw 2 radii to the center, this area right here is a sector. A sector is essentially just a part of the area of a circle. So an arc is just part of the circumference. A sector is part of the area. Remember it like that. And then, so a sector so a sector is just like this area I'm shading in right here with between A and B. So you could describe this as sector AB, for example. Now, okay, so can an arc be a whole circumference? I mean, at that point, it's just called a circle, because if you take the entire circumference, you're literally just making a circle with an arc. And so technically, yeah, it does have to be smaller than a circumference, but really an arc is just essentially, think of it as a part of a circle, not the entire thing. All right, and now Now we'll start getting into some. Now we're getting out of terminology and into some math really quickly. So let's start talking about these two equations. Does everyone know what the area of a circle is and what the circumference of a circle is? Have you seen these equations before? A equals pi r squared and the circumference equals 2 pi r. Is everyone familiar with them? All right, cool, awesome. And so really these are the two main areas of circles that you need to know. Now the thing is about this math is obviously it's not going to be asking you what is a radius, what is a circle. Now you need to be able to apply that into being able to, excuse me, it's my bad, solve a lot of these problems. And so let's start working on the problem with 9/2 right here. Or sorry, let me ask you guys one question before I continue. Okay, let me go to home really quickly and then why is it making me draw? Okay, this is really annoying. Let me go to text and then here, all right, sorry about that. I'm just being done with my computer. And then, all right, so let's say if you have 12 feet of fencing to create a circle. So essentially, you have 12 feet, and then you make that into a circle. What is the area enclosed within that fencing? And you don't have to make this into any like number, like it doesn't have to be a decimal number. Just make it in terms of pi. So essentially, if you guys want to send me the answer of what this question is, you're more than welcome to. But I'll go over it really quickly. So I'll let you guys work on it, and then after about a minute, I will go over it really quickly, and then we'll go on to these exercises. Okay, all right, I'm getting some answers, and let me go over them. Let me go over them really quickly. So you have 12 feet of fencing to create a circle. If all that fencing creates basically creates a circle, that means it's a circumference. The circumference is a circle after all. So it's 12 is circle equals 12 feet, and then we need to find the radius of it. So the radius, and to find the area what's enclosed in the fencing, you need pi, which is a constant. We already know that, and r, which is the radius. We need to know the radius. And so I noticed that, all right, the circumference is 2 pi r. I can get from the circumference to the radius, and then the radius can be used to find the area. So let's start finding the radius. This is our intermediate step to finding the area. So the circumference is 12 feet. If I find r will be equal to circumference over 2 pi. Using algebra 1, you can just divide both sides by 2 pi. You can divide both sides by 2 pi so that you get c divided by 2 pi is equal to r. In that case, r is equal to 6 over pi d. And now you can figure out the area from there. Plug in r for pi r squared, and that's equal to 36 divided by 36, since 6 squared is 35, divided by pi squared. Let me make this a little bit more. Pi squared times pi, which then simplifies further into 36 divided by pi. Since the pi squared, since there's two, like, it's pi squared on the numerator or in the denominator and pi in the numerator, one of them gets canceled out, and one of them in the numerator and the denominator canceled out, leaving only one in the denominator. So your final answer would be 36 over pi b squared. Was everyone able to get how I got from 12 feet to 36 over pi? just essentially like, do you have any problems catching up with me or just like following me? No one? All right. Well, I'm going to move on to the exercise right here, exercise 9.2. Or actually, no. Let's start doing exercise 9.3. I think that one might be a little bit more helpful since it's more math related. So a piece of wire, 72 centimeters long. I'm doing exercise 9.3, everyone, by the way, just in case if you were lost. So a piece of wire, 72 centimeters long, is cut into equal pieces. 2 equal pieces, and each is formed into a circle. What is the sum in square meters of the areas of the circle? So, all right, let's dissect this question. A piece of 72 centimeters is cut into 2 equal pieces. So we automatically know that, all right, so that means it must be cut into 72 divided by 2. So we have 2 circles of 36 centimeters because 72 divided by 2 is 36. And each of them is formed into a circle. Now, the sum in square centimeters of the areas of the circle. So that means each circle has a C equals 36, which means it also has a radius of going. This is similar to the problem that we did earlier, where we went from the circumference to the area. So I'm going to speed through this really quickly. So C is equal to 36, divide that by 2 pi, 18 over pi. And then the area must be 18 over pi squared times pi, which is 18 squared, that is 324, divided by pi squared, multiplied by pi. That just cancels out one of the pi's, and so we get an area that is 324 pi for each circle. And so when we do the sum of the areas of both the circles, we get 324 over pi times 2. 324 times 2 is 648 over pi centimeters squared. And that will be your final answer right here, based on just like figuring out the circumference from 72 centimeters and then going to find the area of each circle. So, all right, this is a similar problem to what we did right here. And now this was mainly just a little bit more just like plugging in an equation and figuring it out from there. But now we're going to have to get a little bit more general with how we're going to deal with circles. So we're going to start working on 9.2. And by the way, please stop me. Please text in the chat before I move on. If you're getting lost, please just tell me if you're getting lost, right? And it'll help me a lot. And don't worry, I'll be fine going over the problem again if needed. So let's, if no one's having a problem with the last 2 problems, I'm going to start working on exercise 9.2. So in the figure on the right, circle B is tangent to circle A. We have circle B, which means that the B is the center of the circle. Circle A is the center of circle A at X. And so X is tangent to circle A right here. Notice earlier how I said tangent is only tangent at one point. That's the one point where it's tangent, where the circles B and A meet. And circle C is tangent to circle A. Same thing with B right here. Circle C, that's the center, is tangent at Y. That means it only touches at one place, which is Y. And circles B and C are tangent to each other at right here. And so if AB is equal to 6, AC is equal to 5, and BC is equal to 9, what is AX? So let's try dissecting into what this is kind of saying. So, all right, so AB, it's literally from here to here. That includes the radius of B and some part of A. That's the first thing I think of. So, all right, we have the radius of B plus some part of A. And then we have AC, which is 5, and that includes the radius of C and some part of radius of A. And then we also have BC, which is the sum of the radii of circle C and circle B. Notice how it's like since it connects both of them, it connects both centers B and C. It must be the radius, since C must go to the edge of the circle. That's the radius after all. And B must also go to the edge of the circle, which is also the radius. So BC is a sum of the 2 radii. And so I'm just making sure that was everyone able to get me right there? Everyone was able to understand? Okay. All right. So okay, so now let's try. Now one thing is like, all right, there's so much variables here. There's different radii that I need to deal with, and I need to figure out what AX is after all. So let's try simplifying this into a few equations, or essentially like trying to define some variables really quickly. So let me go to the right really quickly. So actually, I'm not sure. Let me zoom out. That might work. So all right, let me go down right. Actually, let me just move this right here, I suppose. And then, all right, so we have AC is equal to 5, and that's equal to that's equal to the radius of C, which I'm just going to do RC, plus some let's try doing BC first. So BC is equal to the radius of B plus the radius of C. So in this case, is everyone fine with the notation I'm using? Does anyone have any problems with the notation? Oh, whoops, my bad. And then, okay. So we have B. Let me zoom in just a little bit more so that we can get both of them. All right. So, and now we have, so we know that they're both the radiuses of both. And we know that AB, or sorry, AX is equal to AB plus RB, right? Because we're trying to find AX, and we know that's going to be equal to AB plus another radius. Notice that BX is also a radius too. Let me actually make this a little bit simple. Is equal to that is equal to RB, which that's equal to 5, since AB, or 5 is equal to 6. Sorry, I'm being a little bit slow right now. So we have AX is equal to 6 plus RB. And now we still have one more value we haven't used, AC. And in this case, we have AY is equal to, AY right here is just this line, is equal to AC plus CY. And it's the same thing case with the previous equation. That's just CY is also the radius. And so we have AC, which is 5, plus RC. Now this is now where I'm going to involve you guys in right here. How can we relate these three equations? We have BC is equal to RB plus RC, AX is equal to 6 plus RB, and AY is equal to 5 plus RC. Now use something that try to relate these two equations. Let me AX is equal to 6 plus RB. Let me just delete this really quickly. And AY is equal to 5 plus RC. Try to relate these two equations and be like, all right, which one of these are similar? How do they relate? How do AX and AY relate? Can anyone give me an answer? Okay, all right. So, 1 second. Okay, so so if you guys need any help, think about it like this. What is the radius of circle A? How do, what two, oh, I kind of gave it away a little bit. Which of these lines represents the radius of circle A? Think about it like that. And you will notice that AX is a radius because it goes from the center to the edge. But also AY is also the radius too. And so with that, we can say like, all right, since AY and AX are both radii are equal to each other since it's part of the same circle, we know that AX must equal AY. And so we could do AX is equal to AY, which means that 6 plus RB is equal to 5 plus RC. And then we also have BC is equal to 9. Let me just simplify that really quickly. So now you have these two equations. Let me highlight them really quickly. You have this one right here. Wait, let me highlight that even more. And this one right here. Yeah, so all right, now I think everyone here understands AY and AX are radii, and we can compare. Now we have a system of equations. We have RB plus RC equals 9, and 6 plus RB equals 5 plus RC. And so now we can figure out what RB is and RC is. But I want you to ask, which one is important in answering our question? Is it the radius of B or is it the radius of C? Which one is important in answering our question? What is AX? Okay, good. Yeah, someone told me it was the radius of B. And yeah, because AX includes the radius of B, it doesn't include the radius of C. We don't care about what radius of C is. It's good for us to know maybe, but it doesn't help us in finding our answer. So we can solve for the radius of B. And so in this case, does everyone here know how to solve a systems of equations? I'm not sure if you guys have gone to that part in algebra 2. Okay. So I want you guys to be able to solve for RB. So if you haven't heard me, solve for the radius of B. All right, so after solving a lot of this, and don't worry if you don't have time, if you didn't finish right now, I'm just going to say it right now. The correct answer to the radius of B was 4. And as you can see, 6 plus 4, that's 10, is equal to 5 plus 5. 4 plus 5 is 9, and 4 plus 5 is 9. So it works out in the long run. So now we know the radius of B is equal to 4. And so we can set AX to, remember back this equation, AX equals 6 plus RB. Now we can plug in for the radius of B, which is 4. And that is equal to 10. And so now we figured out AX, which is 10. So, all right. Did anyone have any questions over the process I did? Like, did I go over anything that was confusing or you just didn't understand? All right, Buttercream, ask away. All right, so Buttercream asked, why did you choose BC and AX and AY, specifically in terms of other terms and constants? Well, I think one thing is like it's just a preference for me to do it, mainly because it's just so one of the first things I thought when I first read this problem is like, all right, we're given a lot of numbers, but we don't really like they're not really essentially useful on their own. We needed to combine them in certain ways to figure out a better way. And in certain cases, I always know that, all right, equations are known for combining different things into one like cohesive statement. So I was like, all right, let me see if I can I can combine all of these terms, the A, B, A, C, and B, C into a cohesive statement or into a bunch of equations. And so in this case, I wanted to, and so when I try to express things in equations, I want to use like actual values, actual meaningful values. You can't just I think this is more of like, all right, you can't really just choose like, let's say arc XY, for example. This has no meaning to the problem. I try to choose like things that may have meaning. I obviously don't 100% know all the time whether it does in the long term, but I was like, all right, maybe I could make things simple right here. And another reason why I chose to use radii to express AB, AC, and BC is because I knew just from the get-go that, all right, BC is the sum of the radius of B and the radius of C. That already clicked in my mind when I first saw this figure and then I first saw the number. So I knew the first equation right here. BC is equal to RB plus RC, which is equal to 9. And so if I could tell the other terms within that context, within using the radii, that would get gold because I would be able to use BC's like expression and combine them with AXs and AYs. And oh, look, I'm already saying a cohesive statement with the expressions, with all the equations, and I could use a systems of equations to figure out AX. Did that make sense? I'm sorry if it would sound like a little bit of a word jumble, but long story short, it's like I already knew that the radii were important because BC is the sum of the radii, and I want to make things simple and relatable to pertinent examples, like actual, like meaningful things that I wanted to see. So, all right. So that's one of the major topics of circles right here. This is a relatively medium ish question, mainly because it does give you a lot of information and it gives you a figure too, which is really helpful. So I think now let's start working on let's start working on let me post an actual AMC problem. I think that will be really helpful for you guys because now you can see like what to choose right here. So let me go to I'm just going to copy paste one right here. Just wait 1 second. And then so right here. Okay, now let me go past here. Now it's going to be pasted right here. All right. So in this case, don't want to plagiarize. This is AMC 10B 2015. This is on the AMC 10 problem 9. So it's one of the first 10 problems, which means that it's not going to take you like really long to figure out, or it shouldn't take you long to figure out. So all right, let me read this out really quickly. So the shaded region is made by Leonardo da Vinci, whatever. It's bounded by the portion of the circle of radius 3. So all right, this is the radius 3 right here. And center 0, 0, in the lines of the first quadrant, the portion of the circle with radius 3 halves and center 0, 3 halves that lies in the first quadrant in the line segment from 0, 0 to 3, 0. What is the area of the shark's fin cut up, which in this case is the shaded region? All right, so did everyone understand what the question is asking just before we continue? Because if you don't know what the question is asking, you can't answer the question. So, okay, so everyone read the question, and everyone understands like what it's asking for, not necessarily how to solve it, but they know what you're trying to find. All right, so I'll start off with giving you guys some hints right here. I think I forgot to give you one instance of an equation which could be useful right here. let me go back right here. So when we talk about, I think I just need to mention sectors again really quickly before I continue. So I'm just gonna, let me give you a quick crash course over sectors really quickly. So let me draw a shape, circle right here. And then, so we have sector, this is center right here. We have a sector right here, all right? So let's say the sector is subtended by angle theta, meaning that the angle right here formed by the two radii is some angle theta, all right? We can make it whatever we want. And then let's call this arc AB. All right, so then we have the radius of r. So one important thing that we can talk about is just like some really important equations when it comes to sectors. So the arc of AB is so arc AB is equal to r times theta over 2 pi. All right, so essentially, like for example, if I had, let's say if this theta was 90 degrees, that means I would multiply the radius times 90 degrees and divide it by 2 pi. So essentially, or yeah, this is the length of arc B. Let me be more specific. Length of arc B is r times theta divided by 2 pi. And the thing is like, let's say, and so how this kind of works is just kind of like, if I were to, let me see. Wait, am I being right in this case? I'm not 100% sure. I'm sorry, guys. I'm just having a little bit of a brain fart right now. So it's r times the angle right here divided by, is it divided by 2 pi or divided by pi? I'm not 100% sure. Let me check. I'm sorry. I'm so sorry, guys. I should not be doing this right now. So okay, that's perfectly fine, Ishan. Just come back whenever you can. All right. So okay. So the length of arc B, it should be. So I'll get back to that later. But now we have the sector. The sector here is basically the area right here. Remember back to our discussion back here. So the sector is basically this entire just like pizza slice in a way. The area of that sector, since a sector is really just an area, it's going to be equal to theta. So sector area is equal to theta times pi over 360 times r squared. All right, and then in this case, the length of arc B would be r times theta divided by r times 180. Wait, yeah. It's going to be r times pi divided by 180 times theta. Okay, so here, let me just rephrase everything I said. So essentially, the length of arc AB is equal to r times pi over 180 times theta. So in this case, let's say if r was 1, we'll just use 1, just make it simple. But if theta was 90, that means theta 90 right here. Note, if I were to draw it out, let's say if I did 90 degrees right here, it would be, how would I say it? It would be this right here. This would be 90 degrees. And the arc length of that, or the arc length of that will be r, let's just call that 1, r times 90 over 180, that's 1/2. So it would be 1/2 pi. Now, let's say if theta was 360 degrees, all right? If it were 360 degrees, it would just include the entire circle, right? Because 360 degrees aren't a circle. So that would mean that the length of arc AB would be r times pi over 180 times 360. 360 divided by 180 is equal to 2. And so the length of the entire arc, essentially the entire circle's circumference, is equal to 2 pi r, since 360 divided by 180 is 2 times pi times r. And so the length of arc AB is just another way of showing the circumference of a circle, but only part of it. In this case, now you're going to be dividing it by essentially like basically multiplying it by theta over 360. In this case, like since there's 360 degrees angles, that means theta is going to be so theta is always going to be like less than 360 in this case. And so and degrees are always in 360, since there's 360 degrees in a circle. So you can figure out the length of an area just based on 2 pi r times theta over 360, which is equal to pi r theta over 180. Notice how this equation right here is the same thing right here. So r pi theta, which is just that symbol, divided by 180. So what I'm trying to say is the length of arc AB is just one way of, it's just like basically trying to find a fractional circumference. And then this works for the area too. The area of the entire circle is pi r squared. But if we were to separate that into degrees, it would become pi r squared theta over 360. So like if it's 180 degrees, that's half the circle. 90 degrees, that's 1/4. 45, 1/8. And so in this case, it would become theta on top, r squared on top, pi on top, 360 on bottom. And so in this case, well, we can figure out the area of a sector based on this equation right here too. So these both length and sector areas are derivatives of pi r squared and 2 pi r, which are this area and circumference respectively. All right, so did I lose anyone there? That was a little bit confusing. I would admit that was a bit confusing. Does everyone understand how to find the length based on r and theta and the sector based on r and theta? Just say yes in the chat. Well, no one's saying yes in the chat. Uh-oh. Is everyone okay? Okay. All right. So let's go. So the last thing I'll do today is solving this problem really quickly. And just so that does anyone have any ideas like how you would go about this problem? And I'll give you a hint. You have to use the areas of circles. All right. Buttercream, just text me what you think you will do. Yep, that's pretty much what I would do too. So notice how, if I were to just highlight this big circle right here, like there's this big like sector of a circle that's 1/4 of it. Notice how it's a 90-degree angle here. And then you have a smaller semicircle, which is 1/2 the area of a circle with that radius. And so you can take the big circle, the big sector, and subtract it from the small sector. And so in this case, let's try finding the area of the big sector. So area of big, that is equal to, well, so we know that this is 1/4 of the entire circle. So we can automatically say, all right, if it's 1/4 of the circle, it will be 1/4 the area. So it will be 1/4 times pi r squared. But in the chat, tell me what is r? 3. Yeah, because notice how this right here, this is 3, and it says right here, and bounded by a portion circle radius 3. So we know that r is equal to 3. So now we can figure out the area of the big circle is 3 squared. That's 9. So it would be 9 pi over 4. And think about simplifying. Don't do it unless it's like egregiously big numbers. Like it will be easier for you not to mess up when simplifying that and just leave it be and then simplify at the last moment. Don't simplify right now unless you know it will make the problem easier with fractions especially. Now let's go back to the area of the small sector. All right. So the area of the small sector, this is the sector right here. I notice it's a semicircle, so I know it's going to be 1/2 of the total area, which is pi r squared. And now what is r in this case? You sure it's 3/4? Why is it 3/4? Um, well, just notice how this entire thing is a diameter. So 0 to 3, that's the diameter. And so half of that, this is the radius, and the radius goes from 0 to 3/2. And so the radius is 3/2, not 3/4. That's why so in this case, one person actually Buttercream told me that the radius is 3/4, but that's not correct, mainly because the radius is 3/2. I think you got confused by thinking that the radius of the diameter of the semicircle is 3/2. But in this case, the diameter is 3, thus the radius must be half of that, which is 3/2. And if you read the question, it says right here the portion of the circle with the radius 3/2 and center 0 3/2 lies in the first quadrant. So we already know, all right, this is a radius of 3/2. All right, so we have 1/2 times pi r squared, which means it's 3/2 squared. There's a 9 on top. 4, 9 pi over 4 times 2 because it's still I still didn't include the half. 3/2 squared is 9/4. It's pi divided by 2. So now we have 9 pi over 8. So now I'll let you guys do the rest. How do we combine these two? We have the area of the big and the area of the small. Now, how do we figure out what areas now what do we do so that we can find the area of the shark's fin diff falcata? You can type the answer in the chat if you need to. And actually no, I recommend you type the answer in the chat for me. Or you can just tell me the answer choice which corresponds to it. All right. Who else is in here? Savannah, what answer did you get? Okay, all right. So Buttercream, you got it right. It is B because 9 pi over 4 minus 9 pi over 8 is 9 pi over 8. So, all right, now now we have the final answer here. And based on the time we have, I'll be staying here until 8 o'clock, but you are free to go if you guys want to. So if you guys have time, you guys can stay, and I'll just be doing one more. I'll just be answering questions, like any specific questions you guys have, over like, hopefully just keep it like on topic. Like don't go into a topic over complex numbers when we're talking about geometry, but maybe like give me some like geometry questions that you have, or like any just general ideas that you were wanting to have. But regardless, you are free to go. Thank you guys for coming. And also on the Google Classroom, I'll be posting just anyone who was there. I'll be just posting a survey being like, did I go too fast? Did I go too slow? Or was I just right? Because I'm planning, because this is my first time doing this, and I want to see like how fast do I need to go in like the recordings that I'll do, or not the recordings, but the videos I'll do later this week, and the ones I'll be doing overall, and the ones I'll in the meetings that will happen every Monday. So, all right. All right, so is everyone wanting to stay then, I suppose? You guys are free to leave if you want, but covering next week. All right. So in this video this week, I'll just be talking over angles. I'll just be going over angles, especially when it pertains to circles. So like for example, this is like just a little bit of a sneak peek right here, just in a way. Let me just get a shape actually. So let me go down here. Let's say if you were given like um, if you're given like this shape, let's say for example, all right, and we're given this angle, that the arc of the angle, let's say it's called 26 degrees, and it says 32 degrees, something like that. Just like, what is this angle right here? That's essentially like the problems that we'll be dealing with, essentially, and you could figure out, and based on just this angle right here, you can figure out what this angle here, and same thing right here, you can figure out what this angle right here would be too. And so we'll be discussing that, and I'll be discussing that in the video. But next week, um, I'll be going directly into, I think, triangles, I'm pretty sure, or like getting into just like early triangles, just like talking about like how triangles relate to circles. Because every shape, especially regular shapes, they relate to circles. Essentially, like circle is one of the most like, let's say the most even shape of all. It's literally just a radius circled around a point, and it's one of the most like evenish. And so when we do mathematics, that's how we follow it. We want to make sure we want to relate it back to the circle as much as possible, because a circle is easy to understand. A pentagon, however, is not easy to understand in a lot of cases, and so we like to split the pentagon into separate pieces that become triangles, which are really easy to understand. And so polygons, essentially the general theme of polygons, and really any shape outside of quadrilaterals and triangles, is literally just to split them up into simple parts. But that's really it. Next week, I'll just answer your question directly. We'll be going over triangles, talking about the differences between circumscribed, inscribed, and all that stuff. So that's all. That's all I have for today, unless you guys want to stay and I'll be asking questions. So you guys are free to go. Anyway, thanks again for coming, and I'll be stopping the recording right now. So for everyone watching this video, thank you for watching, and hope you come back and keep following Lubbock Math Club.